this warm up is kind of a review of what we did last class. And here, oh, 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 wow. Okay, that's interesting. I don't know what I just did. Okay, we're talking about this thing called the empirical rule. You might know it as the 68, 95, 99.7 rule. And here we have like heights with a mean of 22 and a standard deviation of 3. Now, before we even do a question, we have to consider, okay, can we actually use the empirical rule or can we not use it? And Michael, do you want to explain why we could use the empirical rule for this question?
Well,
Oh wait, you didn't do that one. Who wrote up number? Hunter, do you want to explain why?
Because it says that they were normally distributed.
Perfect, right? So if it doesn't say this in the question, normal, then you can't do the question. This only works for normal distributions or that bell curve shape, okay? So once we know we can use the empirical rule, we had to find, okay, what percentage of the blocks are between these two numbers, 16 and 28? Michael, do you want to explain how you got this one?
yeah. So it gave us a mean and a standard deviation. So basically what I did, since it told us that it was normally distributed, and I subtracted 22 by 16, and I ended up getting 6.
Oh, I see. Okay.
And if the standard deviation is 3 divided by, or 6 divided by 2 is 3. Or 6 divided by 3 is 2. So standard deviation acts twice. And according to the rule, 2 standard deviations is 95%.
Great. That's a different way than I talk about it, but honestly, that makes perfect sense. It's a little bit different than what I do, but very nice job. Let me just explain how I would go about this question. Perfectly fine how you did it. What I would do, which makes more sense to me, is I would start with the mean, right? And I would just like add on a standard deviation, right? And we get 22, 22, 24, 25, right? Well, that's not 28. So I can just add another standard deviation again, and then I get 28, right? So it seems like 28 is 1, 2 standard deviations above the mean, right? And you can subtract and you'll probably get 16. So I know that I'm within 2 standard deviations of the mean here, which means just looking at the rule, the answer is 95%. That's it. Okay. Nice job on number 2. Any questions so far? All right, number 3, this one asked what percentage of blocks are between 19 and 25? Cass, do you want to take us through this one?
Well, I did like how you said you would do it. I just added, and subtracted 3, and it just happened to perfectly work. So there's only one standard deviation, which is 16%.
Perfect, right? So the percentages are easy. Like once you know how many standard deviations you are away from the mean, the number is literally in the rule, right? So all you have to do is remember 68, 95, and 99.7. Nice job there. Number 4, I wanted to find what heights does about 99.7% of the blocks lie between. So actually we're doing 2 and 3 the other way around, right? So I'm giving you 99.7. I want you to find the 2 heights that they represent. And Melanie, you wrote this one up, right? You want to take us through this one?
So I added 3 times 20 to get 31. And I subtracted it 3 times to get 13. So that means 16.
Perfect job. All right. Any questions on the warm-up? Nice. Okay. Before I talk about the notes, I guess I should have asked this earlier, but is there anyone else who needs a copy of the notes? Good. All right, so why don't we just flip back to our set of notes? The set of notes looks like this. We were talking about distributions and I just fell back on my chair. Okay, so, sorry, there we go. Okay. I think we are all pretty good with this rule now, the empirical rule, but then we kind of shifted over into this new branch, which I kind of drew out for you at the end of class last time, okay? So why don't we consider the fact, okay, we have this rule, and honestly, I wish I wrote this better. where do I want to draw this? That's okay. I'll keep looking at this diagram, even though I drew it very badly. Okay. We talked about the normal distribution. And the funny thing about the normal distribution is that the mean, the median, and the mode is smack in the middle of this bell curve, right? So on the x-axis, I know where the mean is as long as I can find the peak of whatever the curve is, okay? Now, remember we use mu for the mean, okay? And we were able to go 1, 2, and 3 standard deviations above the mean and 1, 2, and 3 standard deviations below the mean, okay? Sometimes it's kind of confusing just looking at this because sometimes we don't want to say 2 standard deviations above the mean or 3 standard deviations above the mean. Sometimes we just want to say a number and have us just know that it means how many standard deviations we are above the mean. So what I did is I said, instead of saying take the mean and add a standard deviation, I'm just going to say z equals 1. And instead of saying take the mean and add 2 standard deviations, I'm going to say z equals 2. So what this z-score does is it tells us how many standard deviations we are above the mean, or if it's negative, we're actually below the mean, okay? And it doesn't have to be a whole number. Z could even be 2.6, which means we're 2.6 standard deviations above the mean. So all we're talking about is we're giving a score that gives a number, a value on how many standard deviations above or below the mean that we are. Okay, we call this a z-score, okay? And the z-score has a specific formula that I'm going to tell you, you do have to memorize, okay? So whenever I talk about a z-score, I really mean a formula which takes a specific data value. And the way to get the score is you're just going to subtract off the mean and divide by the standard deviation. And this will tell you how many standard deviations you are away from the mean. Okay, let's do a couple problems on this so that we understand how to use this formula and actually know what the z-score is talking about when we see a z-score, for example. And in this example, a teacher is giving a bunch of tests to her students. Now, whenever I see a big word problem, I always get really confused. So what I like to do is just like tabulate all the important information in a little table. So I'm not like looking back and forth between the question and the question I'm trying to answer. So let me just fill out this table here. Okay, it says all the versions are normally distributed. Okay, and test version 1 has a mean score of 66. So I'm going to write that underneath the mean here, and a standard deviation of 4. Test 2 has a mean of 66 and a standard deviation of 2. And test 3 has a mean of 72 and a standard deviation of 6. Okay. Now, looking at these test scores, I got this question off the internet. I would never give a test where the mean is 66 and the standard deviation is 4. That would be kind of awful. Hopefully that will never ever happen. Okay, so I organized all the information. I don't have to go back to that paragraph and understand what everything is talking about. Okay, we have Lewis. He received a 76 on test version 3. I want to know what his z-score is, and I want to know what that actually means. Okay, now if you remember, our z-score formula is z equals x minus mean over standard deviation. Okay, and I don't know if this is overkill, but whenever I see a formula, I just like to tabulate all the important information so I'm not ever plugging something in the wrong spot. You don't have to do this, but for some reason I have to do it. Okay. Well, Lewis received a 76. Is that the x value or the z value? Definitely the x value, right? Well, the question is asking what the z-score is, so it's probably not what the z value is. And also 76 is the actual thing that happens in real life. So whenever you're dealing with an actual thing, like a data value that you actually got, that's going to be your x value, okay? Now we're dealing with test version 3, and that mean is 72 and 6. So what we're really doing is we're trying to find what z is. So all I have to do is plug in my values in for each of the spots. It looks like we have z equals 76 minus 72 over 6. Okay. Now, you can do this all in your calculator at once. I like to do the subtraction first and write it down and then do the division, but I'm getting 0.66. Okay. I was about to put 3 sixes. I was like, oh, maybe I should do that. Okay.
Does it have to be? How many digits after?
It doesn't have to be. I'll just leave it at 3. It doesn't matter how much you round it. I wouldn't round it to a whole number, but decimals are fine. Okay. Now we haven't finished the question. This is asking me, okay, what does this mean in terms of standard deviation and the mean? If my z-score is positive, does that mean I'm above the mean or below the mean?
About.
I think I heard above, right? Above, right? So if we have a positive z-score, that means that we're above average. This means he did better than the average, okay? So Lewis scored above average, and we actually have a more reasonable or precise way to talk about how well he did. He didn't just score above average, he scored 0.667 standard deviations above the average. Okay, so now we can talk about how well he did in a more precise manner than just being like, oh, he scored above the mean or he scored below the mean. We actually know how much that he did. Okay. Any questions on number 1? Yeah, not too bad, right? I'm going to make it a little bit more complicated. Let's skip number 2 for now, okay? Let's go to number 3. Okay, number 3. We have Anna. Anna's z-score on test version 1 was negative 1.5. This time I want to know what her test score was. Okay. Whenever I have a formula, I have to write down all the different things because if I don't, I will mess up. I am not very good at keeping things in line, okay? This time I have the z-score was negative 1.5. I guess that means negative 1.5 has to be z, right? Okay. And looking back at my notes, test version 1 had a mean of 66 and a standard deviation of 4. So I'll just type that in. Okay, so this time I'm actually trying to find what x is. Now, taking my formula, all I have to do is plug in all the values. We have negative 1.5 equals x, well, leave that alone, minus the mean over the standard deviation. This time I have to figure out what x is, right? Okay, we have subtraction by 66 and division by 4. Which one should I undo first, the division or the subtraction? The division, right? You do the subtraction first if like x was a number. So that means the division is the thing you have to undo first. Yeah, perfect. So let's undo dividing by multiplying by 4. Okay, 4 times negative 1.5 is negative 6. And the 4's cancel out, which means we have x minus 66 on the right-hand side. Okay, I guess all I have to do is undo the minus 66. The opposite of minus is plus. So all I have to do is add negative 66 to, or negative 6 to 66, and that gives me 60. Then we have x on the other side. Looks like Anna's test score was a 60, which is not very good. Okay. Any questions on what I did for number 1 and 3? All right, I guess you know what's coming next. I want you to give number 2 and 4 a try. Front here, this time we have Jamie receiving a 70 on test version 3. I want to know what Jamie's z-score is. Who wrote this one up? Is that Emma? Do you want to take us through how you did this one?
I subtracted 72 from 70 because you got 70 but after 72.
Mhm.
And then divided by the standard deviation, you got negative 0.33, which means that you scored 0.33 below the mean, or 0.33 standard deviation below the mean.
Awesome. Okay, yeah. So when I read this, at first I thought, okay, totally fine. I don't know why I was reading this wrong. Okay, one thing that I would like really nitpick, I know interpreting a z-score is like kind of weird because you have to write it in words. I saw a lot of people write Jamie scored negative 0.3 standard deviations below the mean. Saying you scored negative below the mean doesn't really make sense. It's not something I would take off points over, but If you were to like say that in real life, it wouldn't make too much sense. So what I usually do is if I'm interpreting a negative z-score, I just take away the negative and say they scored that many below the mean. Okay. Any questions on number 2? Nice. Oh, yeah, like, oh, I scored negative below the mean. That doesn't really make sense, right? All right, let's go to number 4. This time I was given the z-score and I wanted to find Bob's test score. Who wrote this one up? Is that Joey? Nice. Joey, do you want to take us through this one? Mhm. Awesome job. So this time Bob's test score is 70. All right, any questions on number 1 or 4? All right, I think I've burned this into your brain. Hopefully we're all good on this. We do have a test, or not a test review, a quiz review to go over. So what I'm gonna have us do now is the same thing as we've been doing the past couple of weeks. Our quiz 4 will be on